Hey math fans, we're on section 2.9.2. Let's get started. So in this second part of lesson 9, we're going to really take a look at geometric sequences, which are different from an arithmetic sequence because they have a common ratio. Now, the common ratio is going to be defined by this variable r. R will be equal to a number, which is actually quite the same, it's exactly the same as b in our exponential functions. So down here we have the explicit versus the recursive formula for a geometric sequence, which basically just means it's going to be exponential. Example 1, find the common ratio, write the explicit formula, and find the seventh term for the following geometric sequence. Well, the first thing we should do is write that explicit formula. A sub n equals the first term times r, and then raised to the n minus 1. This should look pretty familiar, but instead of the intercept, we're using the first term. And instead of calling the base b, we're going to call it a common ratio r. But notice the similarities. And we've already discussed how when you use the first term versus the intercept, you need to raise the power to the minus 1 power. So first things first, let's find the common ratio r. You find the common ratio r by taking a term, any term, and dividing it by the previous term. So 1.5 divided by 3, 0.75 divided by 1.5. You have to do at least two of these. And we discover that r is equal to 0.5 because we kept getting 0.5 for at least two of them. The final thing we need for the formula is the first term, which is 3. It was given to us. Then all we have to do is substitute those values into the explicit formula. And then we can find the seventh term. So here's our formula, 3 times 0.5 to the n minus 1. And then all I'm doing is substituting in 7 for n. And you get that the seventh term is 0.046875. Example 2, the fifth term of a geometric sequence is 1,792. The common ratio is 4. Write an explicit formula for the sequence and then write the corresponding exponential function. So we'll be using function notation at the very end. So there's that explicit formula again. A sub n equals the first term times the common ratio r raised to the n minus 1 power. R is equal to 4. I mean, that was given to us in the problem, but we don't know the first term. What are we going to do? We don't have that first term to finish the explicit formula. We do have the fifth term. And so using the formula, we can actually set the formula equal to that 1,792. And because it's the fifth term, I will substitute 5 in for n. And then we can solve for the first term. And when we solve for a sub 1, or the first term, we get that first term is equal to 7. Now we're all set. The first term is 7. R is equal to 4. Substitute the values in, and you're done. The final step is to put it into an exponential function. So we'll just change a sub n to f of x and the n to an x. Example 3, a geometric sequence is defined recursively by a sub n is equal to a sub n minus 1, remember that's the previous term, times negative 1/3. And they're giving us that the first term is 729. Then it says find the first 5 terms, write the explicit formula, and then find the 8th term. Because this is a geometric sequence, remember, we multiply by the common ratio. So if the common ratio is negative 1/3, we're going to be multiplying. And so my second term is going to be 729 times negative 1/3, which is negative 243. And you just keep multiplying by negative 1/3. So there are your first 5 terms. Writing the explicit formula is pretty easy because in the recursive formula, they already gave us the common ratio, and the problem gave us that the first term is 729. So there's the explicit formula. Now we can use the explicit formula to find the 8th term. So we'll substitute 8 in for n. So we'll say the 8th term is going to be equal to 729, actually times 1/3 to the 7th power. And we get that the 8th term of the sequence is negative 1/3. And that's going to do it for this section. We'll see you in class.